Hello everyone, this is your Kalpana here. In this video, we're going to solve a differential equation using variation of parameters method. So I'm going to show you the solving of a differential equation using variation of parameters method in 3 different ways. So let's get going with part 1. We are given a differential equation. Okay, problem solve d square plus 2d plus 1 into y equal to e power minus x log x, or y double dash plus 2y dash plus y equal to e power minus x log x using variation of parameters method. So the first equation is the operator form of the second equation. So both equations are same and we are given a differential equation of order 2. Given differential equation, y double dash plus 2y dash plus y equal to e power minus x log x. Okay, we know that y double dash or y2 is nothing but d square y by dx square, that is double derivative of y, and y dash is or y dash or y1 is nothing but dy by dx, right? We can ask the same equation as y2 plus 2y1 plus y equal to e power minus x log x. Okay, now let's write y double dash as d square y by dx square plus 2 into write y dash as dy by dx plus y equal to e power minus x log x. Now we'll use the differential operator d. Now we can write the equation as d square y plus 2 dy plus y equal to e power minus x log x. Now take y common from the three terms of LHS. We'll get d square plus 2d plus 1 into y equal to e power minus x log x. So consider the first equation as equation number 1 and this equation in operator form as equation 2, which is in equation form say f of d into y equal to r of x, right, which is in operator form where f of d is d square plus 2d plus 1 and r of x is e power minus x log x. Let's now write the homogeneous equation of equation 2. D square plus 2d plus 1 into y equal to 0, consider as equation number 3. Now we'll find the solution of equation 3 using the auxiliary equation, and later using the solution of the homogeneous equation we'll find the solution of equation 2 and equation 1. Okay, so let's see that. The auxiliary equation is f of m equal to 0, where f of m equal to, we have f of d square plus 2d plus 1, right? So let's replace the differential operator by m, so that we'll get f of m equal to m square plus 2m plus 1. Then the auxiliary equation becomes m square plus 2m plus 1 equals to 0, right? Now we can write this equation as, we can write 2m as 2 into m into 1 plus write this 1 as 1 square. This is of the form a square plus 2ab plus b square, which is an expansion of a plus b whole square. So we can write it as m plus 1 whole square, or m plus 1 into m plus 1 equal to 0. Now we equate each factor to 0. When m plus 1 equals to 0, we'll get m equal to minus 1. Since m plus 1 is repeating twice, then we'll get m equal to minus 1, which is unequal root or repeated root, we can say. Therefore the roots are real and equal. We know that when two roots are real and equal, say m1 and m2 are real and equal, then the solution of homogeneous equation looks like c1 plus c2x into e power that equal root into x. Okay, but here we'll take C3 and C4 instead of C1 and C2 because I want C1 and C2 to appear in the last general solution. Okay, so I'm taking C3 and C4 instead of C1 and C2. Now coming to the solution of homogeneous equation. The solution to homogeneous equation is y equal to C3 plus C4x into e power equal root, which is minus 1 into x. This gives us C1 plus C4x into e power minus x, or y equal to C3 e power minus x plus C4x e power minus x. Okay, both are same. So y equal to C3 plus C4x into e power minus x, or C3 e power minus x plus C4x e power minus x is a solution of homogeneous equation. So I am taking the second one for my convenience. Let y equal to, just replace the constants or parameters with functions of x, a and b, then we'll get y equal to a e power minus x plus bx e power minus x be the general solution of the given equation of 1 and 2, where a and b are functions of x. We need to find a and b. Okay, see, we are saying that y equal to a e power minus x plus bx e power minus x is a general solution of 1 and 2, which is nothing but it is a solution of equation 1, right? So we can say that this satisfies equation 1, right? So we can substitute this in equation 1. In order to substitute y in equation 1, we need y dash and y double dash also. So let's find y dash and y double dash. We have y equal to a e power minus x plus bx e power minus x, right? We'll find y dash. Y dash is given by a e power minus x whole dash plus bx e power minus x whole dash. This gives us a dash. Here we are going to apply uv whole dash formula, which is equals to u dash v plus v dash u, right? We'll get a dash into e power minus x plus a into e power minus x whole dash plus b dash into x e power minus x plus b into x e power minus x whole dash, right? This gives us a dash e power minus x plus a into derivative of e power minus x is minus e power minus x plus b dash x e power minus x plus b times, again we are having two functions, so we'll apply uv whole dash formula here. We'll get x dash e power minus x plus x into e power minus x whole dash, right? This gives us a dash e power minus x plus into minus minus a e power minus x plus b dash x e power minus x plus b times derivative of x with respect to x is 1 into e power minus x plus x into derivative of e power minus x with respect to x is minus e power minus x. This gives us a dash e power minus x minus a e power minus x plus b dash x e power minus x plus b times 1 into e power minus x is e power minus x plus into minus minus x into e power minus x, right? Which is equals to a dash e power minus x minus a e power minus x plus b dash x e power minus x plus b into e power minus x is b e power minus x plus into minus minus b x e power minus x. This gives us y dash equals to a dash e power minus x minus a e power minus x plus b dash x e power minus x plus b e power minus x minus bx e power minus x, right? Now let's write the terms involving a dash and b dash. We'll get a dash e power minus x plus b dash x e power minus x. Now write the remaining terms involving a, b. We'll have minus a e power minus x plus b e power minus x minus bx e power minus x. Now let a dash e power minus x plus b dash x e power minus x equals to 0. Let a dash e power minus x plus b dash x e power minus x equals to 0. Consider it as equation number 4. So that while finding y double dash, a double dash and b double dash will not appear, right? So we'll get y dash equals to 0 minus a power, we'll just put or replace it with 0. B plus e power minus x minus bx e power minus x. From this we'll get y dash equals to minus a e power minus x plus b e power minus x minus bx e power minus x. Now we are having y dash. Let's now find y double dash. We have y dash equals to minus a e power minus x plus b e power minus x minus bx e power minus x, right? We are going to find y double dash. Y double dash equals to minus a e power minus x whole dash plus b e power minus x whole dash minus bx e power minus x whole dash. Here also we are going to apply uv whole dash formula, which is equals to u dash v plus v dash u. This gives us minus of a dash e power minus x plus a into e power minus x whole dash plus b dash e power minus x plus b into e power minus x whole dash minus b dash into x e power minus x plus b into x e power minus x whole dash. This gives us minus of a dash e power minus x plus a into derivative of e power minus x with respect to x is minus e power minus x plus b dash e power minus x plus b into derivative of e power minus x with respect to x is minus e power minus x minus of b dash x e power minus x plus b into, here we are having two functions, so we are going to apply uv whole dash formula again. U dash v minus plus u into v dash. Okay. This gives us minus of a dash e power minus x plus into minus minus a e power minus x plus b dash e power minus x plus into minus minus b e power minus x minus of b dash x e power minus x plus b of derivative of x with respect to x is 1 into e power minus x plus x into derivative of e power minus x with respect to x is minus e power minus x. This gives us minus of a dash e power minus x minus a e power minus x plus b dash e power minus x minus b e power minus x minus of b dash x e power minus x plus b times 1 into e power minus x is e power minus x plus into minus minus x into e power minus x, right? Which gives us minus of a dash e power minus x minus a e power minus x plus b dash e power minus x minus b e power minus x minus of b dash x e power minus x plus b e power minus x plus into minus minus bx e power minus x. Right? This gives us minus a dash e power minus x minus into minus plus a e power minus x plus b dash e power minus x minus b e power minus x minus b dash x e power minus x minus into plus minus b e power minus x minus into minus plus bx e power minus x. Right? Again, this gives us, first write the terms involving a dash and b dash. Will get minus a dash e power minus x plus b dash e power minus x minus b dash x e power minus x. Now write the terms involving a. Will have plus a e power minus x, then b minus b e power x minus b e power x is minus 2b e power minus x plus bx e power minus x. This is a y double dash. We have equation 1, y double dash plus 2y dash plus y equal to e power minus x log x, right? Let's now substitute y double dash and y dash and y double dash in equation 1. We get y double dash is minus a dash e power minus x plus b dash e power minus x minus b dash x e power minus x plus a e power minus x minus 2b e power minus x plus bx e power minus x plus 2 times y dash minus a e power minus x plus b e power minus x minus bx e power minus x plus y a e power minus x plus bx e power minus x, right, equal to RHS e power minus x log x. This gives us minus a dash e power minus x plus b dash e power minus x minus b dash x e power minus x plus a e power minus x minus 2b e power minus x plus bx e power minus x minus plus into minus minus 2a e power minus x plus 2b e power minus x plus into minus minus 2bx e power minus x plus a e power minus x plus bx e power minus x equals to e power minus x log x. Okay. This gives us minus a dash e power minus x plus b dash e power minus x minus b dash x e power minus x. So here minus 2b e power minus x and plus 2b e power minus x gets cancelled. Okay. Now here you're having a e power minus x, a e power minus x, which becomes plus 2a e power minus x, and here again you're having minus 2a e power minus x. Okay, and bx e power minus x plus bx e power minus x is plus 2bx e power minus x. Again you're having minus 2bx e power minus x equal to e power minus x log x. So here plus 2a e power minus x minus 2a e power minus x gets cancelled, and plus 2bx e power minus x minus 2bx e power minus x gets cancelled. From this we'll get minus a dash e power minus x plus b dash e power minus x minus b dash x e power minus x equals to e power minus x log x. Consider it as equation 5. So now by solving 4 and 5 we'll get a dash and b dash. So let's find a dash and b dash by solving equation 4 and equation 5. Let's solve equation 4 and 5. A dash e power minus x plus b dash x e power minus x equals to 0. Minus a dash e power minus x plus b dash e power minus x minus b dash x e power minus x equals to e power minus x log x, right? So here plus a dash e power minus x and minus a dash e power minus x gets cancelled, plus b dash x e power minus x and minus b dash x e power minus x gets cancelled, and we'll get b dash e power minus x equals to e power minus x log x, right? Now just take this e power minus x to RHS and we'll get b dash equals to e power minus x log x by e power minus x, where e power minus x gets cancelled and we'll get log x. Therefore b dash equals to log x. And we have equation 4, a dash e power minus x plus b dash x e power minus x equals to 0, right? We have 4 a dash e power minus x plus b dash x e power minus x equals to 0. From this we'll get a dash e power minus x equals to minus b dash x e power minus x. Now take this e power minus x to RHS, then we'll get a dash equals to minus b dash x e power minus x by e power minus x, right? Where e power minus x gets cancelled and this equals to minus b dash x. Now replace b dash by log x, which is equals to minus log x into x, or from this we'll get a dash equals to minus x log x. So we got a dash, therefore a dash equals to minus x log x. We got a dash and b dash. Let's now find a and b using a dash and b dash. Let's now find using a dash. We have a dash equals to minus x log x. We can write a dash as derivative of a with respect to x, or a dash is nothing but derivative of a with respect to x, right? Which is equals to minus x log x. From this we'll get dA equal to minus x log x dx. Simply here the variables are separable. In order to separate the variables, we are taking the differential dx to RHS, right? Now the variables are separable. We can perform integration. Integral dA equal to minus integral x log x dx. Let's find integral x log x dx using integration by parts formula. Integral u dv equal to uv minus integral v du, right? We'll just find integral x log x dx, okay? Here the integrand is of polynomial, product of polynomial logarithmic function, right? Let's write it as log function into polynomial function into dx. Now consider the logarithmic function as u and the remaining part as dv, right? We have u equal to log x and dv equal to x dx. Now differentiate on both sides with respect to x. We'll get du by dx equals to derivative of log x with respect to x is 1 by x. From this we'll get du equal to 1 by x dx, right? And here integrate on both sides. We'll get v equal to integral x dx is x square by 2. Now apply this formula. We'll get integral u dv, u into dv, that is x log x dx equal to u into v, u into v, that is x square by 2 log x minus integral v, x square by 2 into du. Du is 1 by x dx, right? Here 1x gets cancelled and we'll get x square log x by 2 minus 1 by 2 into x dx, which is equals to x square log x by 2 minus 1 by 2 into integral x dx is x square by 2 plus integral constant is c, right? So from this we'll get integral x log x dx equals to x square log x by 2 minus x square by 4 plus c, right? We'll get x square log x by 2 minus x square by 4 plus c. Okay, so let's take constant c1 here. Now coming to integral dA, since integral x log x dx equal to x square log x by 2 minus x square by 4 plus c, then this becomes integral dA is a equal to minus of x square log x by 2 minus x square by 4 plus integral constant say c1. Okay, this gives us a equal to minus x square log x by 2 minus into minus plus x square by 4 plus c1. So we got a, let's find b. We have b dash equals to log x. B dash is nothing but derivative of b with respect to x. Let's now separate the variables by taking differential dx to RHS. Then we'll get db equal to log x dx, where the variables are separable. So we can perform integration. Integral dv equal to integral log x dx. Let's evaluate integral log x dx using integration by parts. Integral u dv equal to uv minus integral v du. So here the integrand is of the form 1 into some log x dx, or we can write it as integral log x into 1 into dx, right? Now the product is of, the integrand is of product of logarithmic function and constant polynomial. Let's take the logarithmic function as u and the remaining part as dv, right? So we have u equal to log x and dv equal to 1 into dx, which is equals to dx, right? Now differentiate on both sides with respect to x. We'll get du by dx equal to derivative of log x with respect to x is 1 by x. From this we'll get du equal to 1 by x dx, right? Here integrate on both sides. We'll get v equal to x. Now apply the formula. Integral u log x into v dx equal to u into v log x into x minus integral v x into du. Du is 1 by x dx. Cancel b. We'll get x log x minus integral dx, which is equals to x log x minus x plus some constant, say c. Okay. Therefore, integral log x dx is x log x minus x plus c. If you are really good at remembering the formula, you can just directly write integral log x dx equals to x log x minus x. And if you are poor at remembering the formula, you can just use integration by parts to find the formula. Sometimes we'll be forgetting the formula, right? So it's better to apply integration by parts. Integral log x dx. I'll just apply the formula here. We'll get integral db equal to integral log x dx is x log x minus x. So here integral constant is c2. Therefore, b equal to x log x minus x plus c2. We got a and b, right? So let's now write the general solution using y equal to a e power minus x plus bx e power minus x. Therefore, the general solution is given by y equal to a e power minus x plus bx e power minus x. Now substitute a and b. We have a minus x square log x by 2 plus x square by 4 plus c1 into e power minus x plus b. X log x minus x plus c1 into x e power minus x. This gives us, let's take e power minus x common. Okay, just write by multiplying all the terms with e power minus x. We'll get minus x square log x by 2 into e power minus x. Let's write it as minus x square e power minus x log x by 2, okay, plus x square or 1 by 4, x square e power minus x by 4 plus c1 e power minus x plus x into x square e power minus x log x minus x into x square e power minus x plus c1x e power minus x. So it's c2, right? Fine. Now write the terms involving c1 and c2. We'll get c1 e power minus x plus c2x e power minus x. Now write the terms involving log. We have plus x square e power minus x log x minus 1 by 2 x square e power minus x log x. Now write the terms involving x square e power minus x. We'll get plus 1 by 4 x square e power minus x minus x square e power minus x, right? This gives us y equal to c1 e power minus x plus c2 x e power minus x plus take x square e power minus x log x common from these two terms. We'll get x square e power minus x log x of 1 minus 1 by 2, right? Now take x square e power minus x common from the last two terms. We'll get x square e power minus x of 1 by 4 minus 1, which gives us 1 minus 1 by 2 is 2 minus 1 by 2, which is 1 by 2, or 1 minus half is half. 1 by 4 minus 1 is 1 minus 4 by 2, which is equals to minus 3 by 4, right? This gives us c1 e power minus x plus c2x e power minus x plus x square e power minus x log x into 1 by 2 plus x square e power minus x into minus 3 by 4. Right? Now we can take x square e power minus x and 1 by 2 common from these two terms. Or we can write minus 3 by 4 as minus 3 by 2 into 1 by 2. Okay. Now take e power minus x common from the first two terms. We'll get c1 plus c2x into e power minus x. Now take 1 by 2 x square e power minus x common from the next two terms. We'll get log x, right, minus, you can write minus 3 by 4 as minus 3 by 2 into 1 by 2. So it will be easy to take 1 by 2 common from these two terms. Okay. So I'll get, okay, minus 3 by 2, right? Easy. Or you can include one more step. Let's write one more step. This is equals to c1 plus c2x into e power minus x, just taking e power minus x common from the first two terms, plus x square e power minus x log x of 1 by 2 plus x square e power minus x into, I'm going to write minus 3 by 4 as minus 3 by 2 into 1 by 2, so that it will be easy to take 1 by 2 common from the next two terms, right? c1 plus c2x into e power minus x plus, now take 1 by 2 x square e power minus x common from the next two terms. We'll get 1 by 2 x square e power minus x of log x minus 3 by 2. Therefore, y equal to c1 plus c2x into e power minus x plus x square e power minus x by 2 of log x minus 3 by 2 is the required solution. So we have seen a problem from variation of parameters method in this video. I hope you will understand. We'll see you in the next video. Until then, bye bye.